Hello, geometry students. Okay, so today we're going to do a little group practice, then an independent practice. We're starting to talk about circles. We did a little bit of stuff with arcs and arc lengths, and now I'm going to come to the idea of, well, how can we use these arc lengths? Let's say I was going to make a fence that's going to be circular, but I'm only going to use part of the circle. I'm not going to use a whole thing. Let's say, I want to around my house. So this is the top view of a house. I don't own a house, but I want to put a circular fence, maybe to keep my emu in. And so I made a circular fence like that. How much fencing would I need? Okay, well, if this is a right angle, 45, let's see, the emu needs, about, let's say, 7 feet. So how much fencing am I going to do here? We'll come back to that question eventually. So my emu, I don't know why I picked an emu. That was the first animal that came in my head. And that'll be his playpen, my emu playpen. Built off the side of my house where my emu runs around and keeps busy while I'm at school teaching. Okay, so a car has a circular turning radius of 16.1 feet. The distance between the two front tires is 4.7 feet. How much farther does the tire on the outside turn than the tire on the inside? Interesting idea, because if you guys ever watched NASCAR, I am not really a NASCAR fan. But NASCAR, those guys always are going around in circles. Their general courses are either oval shaped, but they always are making left turns. If you ever noticed that, they never ever make a right turn. Very rarely they make right turns. They're always going in one direction. So out over the course of a race, I think the Daytona 500. Let me Google search this. How many laps is it? How many? How many laps is the Daytona? I think is that 500 the number of laps? 200 laps. Okay, so they have, if they do the Daytona 500, which I guess is the biggest NASCAR race you can do, it's a 500-mile car race, and on that strip they have to do 200 laps. So I don't know how long that makes that track. Each track must be 500 divided by 200. 2.5 miles. So that track at Daytona, we just found that out, is 2.5 miles. So they do that so they have to do that 200 times in the race, go around that. But the idea is that the Daytona track, if I'm looking at the picture here correctly, it's kind of like this. Not really a oval. It's got this kind of part over here that prevents it from being a perfect oval racetrack. It's got a little bit of a different dimension to it. But if the cars are going one direction all the time, I believe they go that way, if I'm correct, right? They are only if you think about it, let's say they're going in that direction, they're only making left-hand turns. So the wheels on this side are going to travel much farther than the wheels on that side, if you want to think about that. So which tires are going to wear out faster? And the one thing I've always noticed about the NASCAR races is that the guys are always pulling in and changing tires. They change tires a lot over the course of, the track. They go through, multiple pairs of tires in one race. So this would tell me that the outside tires, if you're going this way, your right-hand side tires, the passenger side tires, will probably wear out much quicker than the left-hand side, because they're, over the course of 200 laps, that's a lot of distance. It's going to add up, okay? So The idea is how much further does one go to the other? So there's two circles here. Now, if you remember, the circles don't have a perimeter. They have what we call a circumference. And our circumference is either 2 pi r or pi d, depending on what type of information we have. Well, I got to look at two circles. And this is not very clear here. I have one here that's 16, has a circular turning radius of 16.1 feet. And that goes all the way to here. And the distance between the two tires is 4.7 feet. Okay, so how are we going to figure this out? All right, well, I have two circles, and I can find the circumference for both of them. First one's going to be relatively easy, right? 2 pi r. These are radius. Now, a radius looks like this, starts in the center and goes to one side. That would be what a radius looks like. A diameter goes through the center and out the other side. So you have to determine what you have, a radius or a diameter, but a diameter equals a radius times 2, and a radius equals a diameter divided by 2. So basically I'm saying the radius is half as big as the diameter is twice as big as the radius. So if you know one number, you can usually figure out the other. I'm going to take it easy, and since I have radius here, a radii, proper math term, of 16.1, I'm just going to plug in this. C equals 2 pi 16.1. Calculator problem. Don't even bother. Don't even bother not doing a calculator problem. I'm going to have to turn the light on here. Sorry. Whoa, that's bright. Okay. 2. Now remember where to find your pi times 16.1. So that gives me the outside tire will travel 101.15. I'm going to say 101 feet. I'll round up to the nearest whole number. Now, if for some reason you can't find pi in your particular calculator you're using, I would have substituted in 3.14. Is a pretty good estimation of pi. Let's see how close it'll get us. 101, pretty much the same. That's a pretty good guesstimate. So if you can't find the pi button on your calculator, there's 2 times 3.14 times 16.1. So I'm going to write that over here in our lesson. Pi equals 3.14. If you want to do it that way and not search for the pi button. I happen to like nice precise numbers, so okay, so this is the outside tire. Now, how far does the inside tire go? Well, they don't give me a radius from here to here. All they give me is the distance from here to here. So what I can do is, I can take 16.1, and I can say, well, I'll subtract this, because it only comes to here. But I just have to subtract 4.7. And that will give me the radius from here to here. So let me do that real quick. 16.1 minus 4.7 is 11.4. Same thing. That's my radius now. So I'm going to use the same thing. So this is outside tire. Now, 2 pi r, C equals 2 pi. My r in this case is 11.4 for the smaller tire. Well, the smaller radius. So let's put that in there. 2 times pi times 11.4. 71.62. Let's round it up to 72. So in one turn, just just in one turn around all the. Sorry, guys, my computer just had a little problem, but I got it back. Okay, 72 is the inside tire. So how much more does the tire travel than the inside tire, tire travel than the inside tire? Well, that's a question of difference. 101 minus 72. So in a rough estimate, for every time it does a complete circle, a tight little circle like that, which is not a very big circle, that's like turning pretty hard, the outside tire travels 30 more feet. Well, 29. But, I would say we, average about 30 there. Interesting thoughts. So as I said, if you watch NASCAR, and I don't really, but if you think about how much this number could add up over 200 laps or 500 miles, you could see how much more the outside tires need to be changed than the inside tires. And there's also different types of friction on, there's the frictional forces on them too. So, all right. The email. How much track do I need there? I'm going to come back to that on the next question. All right, guys. Be good. I'll be back with the other one.